All right, here's example 1.30 from OpenStax PreCalculus. More average rate of change. The only difference is this time the way the function is represented is not with a table like it was in the previous example. It's with the graph. But the same principles still apply. I'm still going to use my average rate of change formula, which tells me the average rate of change is the difference in the outputs divided by the difference in the inputs. Note that my average rate of change function, I always use the x's to represent the inputs and f of x to represent the outputs. In this specific example, the input is the letter t and the output is g of t. But I don't rewrite a new formula for every single problem. I use this formula and just kind of make it work. And so the way I'm going to make it work is I want the average rate of change on the interval from -1 to +2. So my x1, I'm going to call it -1, and my x2 will be +2. And yes, I realize those are really t's in the context of this problem because the variable here is a t. But I'm going to call them x's so that I can make this formula work. So let's see, x2 was 2. Minus x1 is -1. Be a little bit careful there. We're subtracting a negative. Be really easy to do 2 minus 1 here. And then on the numerator here, I need the output that corresponds with those two inputs. So first I want f of x2. And to figure out f of x2, I'm asking myself what comes out of this machine when I put x2 into this machine. And x2 we decided was 2. So here is the input 2. The output here would be 1. So f of x2 equals 1 because the height right here is 1. So I'm going to throw a 1 right here. Similarly, f of x1, well, x1 I decided was -1, which is right here in the graph. And the output corresponding with this input is way the hell up here. So I got f of x1 is equal to +4 because of this point right here. So here's my fraction that I'm going to evaluate. 1 minus 4 is -3. And careful, 2 minus -1 is the same as 2 plus 1, which is +3. So I got -1 as the average rate of change. You don't have to go any further here, but just a little commentary. Note that really what I'm doing is I'm calculating the slope of the line that goes through those 2 points. So you can kind of check your answer for reasonableness. If you're afraid that you screwed up some simplification here, you can look at this line, this red dotted line right here. What's the slope of that line? I mean, it looks like it goes down 1 every time it goes over 1, right? It looks like our diagonal line except going negative. So I should have a negative answer, and it looks like it's about -1, maybe even exactly -1, which is what it ends up being here. So nice little built-in check. All right.